Good evening. We are part of Group 3 and we will be performing the execution for Knime. That is assignment 1. So we'll proceed from here.
So the problem was the smart city traffic weight prediction, and in that we have the introduction and problem statement, which we need to show the Knime workspace, and based on the Excel datasheet that was provided to us. Today our team is building a machine learning model to solve a classic smart city problem, which is predicting traffic light wait times. So we are using the given dataset that includes vehicle count, weather intensity, road types, and here our goal is to predict the waiting time variable so that city can optimize traffic flow. Here what we will do is we'll just use some nodes from Knime and build a machine learning model and then validate it with the predictor, and then ultimately we'll check the prediction time with the actual ones.
So we'll start by importing our XLS file. A critical step here is the transformation tab. To avoid errors in our accuracy scores, we are ensuring that waiting time sec and vehicle count variables are explicitly set as number or integer. If Knime reads these as strings, the model will fail to perform the math on them.
We have inserted the node of Excel reader, in which we will upload the said Excel file. So here we will browse our Excel file. And we'll check for row ID and other parameters if they are valid. And we'll apply in. So we'll execute this and see that all the variables and the data of the sheet is loaded in the Knime platform. We will also upload the number reader so that we can convert the existing data of waiting time, the road type of time of the day to numbers. So here we will introduce number node. So we will use the category to number node, connect the endpoints.
So Akshay has already covered the part where we moved category to number node and connected it. And so machines don't understand morning peak or arterial road types. They only understand numbers. And I am using category to number node to map these text level into numerical values. I have specifically excluded the wait time column from this node to ensure that we don't accidentally turn our target data into meaningless category IDs. So we'll open the configuration to show only time of the day and road type in the include list.
Here we can clearly see this time of the day and road type is being converted into numbers.
All right. Now that we have converted some of the text fields into numbers, which the machine can understand, now we would want to segregate our data into training and testing data. So we would proceed to add the table partitioner node. So if we go and search that, yeah, so we'll go and search table partitioner. Yeah, so we'll drag it and we'll connect the category to number node with table partitioner. Yeah, so we'll change the relative size to 80 because 80-20 is the ideal ratio to go with, and we'll then proceed with the execution. Now, from here, the important decision here is to select what model we would proceed with to do the analysis. Now, ideally, linear regression is the first model that comes to our head. But in this case, we would proceed with random forest regression after quite some discussion. The reason being because traffic data is noisy and pretty much non-linear. So rain or emergency vehicles don't just add a fixed amount of time. They create complex interactions. So random forest, what it will do is it will handle these interactions by building multiple decision trees, making it much more robust for smart city sensor data. So we can go ahead and search the random forest predictor regression node and then tag it.
We've made a slight mistake. Instead of the learner, we added the predictor first. So we're gonna reset the connections and have the learner first. The learner then connects to the random forest predictor. That's what Akshay is doing right now. Okay, so the random forest learner has been put in place. Now with the random forest learner, we will then connect it to the predictor. Right, so the predictor is then connected to the numeric scorer. So the numeric scorer is basically the entity that gives us the numeric score for our entire prediction. Once we put the data into our model, the numeric scorer gives out whatever we are looking for. I mean, the things that we are looking for are the R-square value and the mean absolute error value. Ideally, in a situation where we want to show that there is some correlation, we would like the R-score value to be as close to 1 as possible. So let's see what value we get. Akshay is still connecting the elements, and then once the numeric scorer is connected, we'll add the data. Okay, selecting the reference column and the predicted column. All right, so we've executed our entire model, and now we see that the R-square value is 0.7, and the mean absolute error value is also quite low. But the important thing that we need to see is that R-square is 0.7 and 0.7 is close to 1, and 0.7 also means that it is the model predicts good correlation, and this model can be used to predict our traffic and also reduce the congestion within the city.